Today we are going to see certain problems that are based on the dynamic programming, and in the last class we already have seen one problem, that is the knapsack problem in the dynamic programming. So using that knapsack problem we are going to solve certain more problems. You can say knapsack problem is a base problem for upcoming problems, and we are going to see some problems like equal partition and subset problem. These problems we are going to see how these problems are similar to knapsack problem and then how we can solve them using the dynamic programming. Hello everyone, this is Sharda from GoEdu Hub Technologies, and today we are going to see certain problems that are based on the knapsack problem in the dynamic programming. Guys, can you please confirm me in the chat window, am I audible, clear and loud, so that we can start the session? Okay, so let me start now. In the last session, first of all, I'll recap for the last session what we have done in the last session. In the last session, we have seen the introduction of dynamic programming. After that, we have seen one problem, that is the 0-1 knapsack problem. Okay, so you know what is the 0-1 knapsack problem? Okay, and today we are going to see certain problems that are based on 0-1 knapsack problem. Okay, this knapsack problem we can solve by using three methods. One is the recursion, that you know we have seen the code. Okay, another one you can say we can write the recursion and then we memorize. Okay, after the recursion we can memorize the things, we can store the recursion result into the another some variables, and then we can solve this using the dynamic programming. Okay, and one method is top-down approach. Okay, so memorization, and then you can say one approach is top-down approach. In the top-down approach, what we are doing, whatever we have done in both ways, we will use this. Like you can say this is, in this approach we are using recursion plus memorization. Okay, basically here we are not using the recursion. The logic which we have used in the recursion we are going to write in the iterative way. Yes, Soumya, I'll see that and we will complete that. Don't worry about the assignments. We will complete that. You regularly visit our Facebook page and LinkedIn page. You will get that. Just right now, just focus on the class, what we are studying. Basically, this is very important topic, you know, dynamic programming. And this is very confusing also. Sometimes what happens, we are not able to recognize a problem can be solved using the dynamic programming or not. Okay, so I'll tell you certain ways how can you recognize a problem can be solved with the help of the dynamic programming, and then how can we write the coding part. Okay, so there are the two ways. I told you in the last class, there are the two ways. By seeing the problem you can recognize easily where we can apply the dynamic programming or not. First thing is the choices. You need to find out in the problem either you are including certain items or not. Okay, and second thing is you are getting some optimal solutions. Optimal solution means you are trying to find something like this, max or min or largest, something like this. If you are trying to do two type of solution in a problem, then you can think about the dynamic programming. Like we can solve a problem using the dynamic programming. Got it? Now you know this 0-1 knapsack problem. In the 0-1 knapsack problem, what we are having actually, here we are having two arrays and one bag that having certain capacity. Like I can say in the 0-1 knapsack problem, just I'm revising for the few minutes because this is very important. All the other problems we are going to solve that are based on the 0-1 knapsack problem. Okay, so here we are having one array that is the weight. Okay, one array having certain weights like 4, 5, 8, and 2, something like this. And one array that having certain values, you can say price. Certain values like 2, 6, 8 and 3, something like this. Now we want to fit these things into a bag, a knapsack, or you can say a bag. That bag having certain capacity. It can hold the weight, you can say 8 only. So what we have to do, we have to fit the particular values, like particular weights, so that we will get the maximum profit. And these values you can say price. So we can get the maximum profit. So when we get the maximum profit, when we are putting higher weight value. Like the value which having higher price, The value which having higher price, like if I'll put this 8, this having maximum price. In place of if I'll put the 4. Okay. So there are the something I have to pick the values like this, certain weights, so that I'll get the maximum price. And I can fit into this capacity only. Are you getting the things? So here, this is the base thing. Here we need to find out certain weights that we are going to fit into this bag. For this, what we can write the recursion, we can write after the recursion, we can memorize the things, and then we can use this top-down approach. In the top-down approach, what we are doing, we are creating a matrix. And inside the matrix, we are storing certain values. So if you are clear this recursion thing, how to write the program with the help of the recursion, then you have done 80% of your work. After that, you can do this second step also, you can do this third step also. Both are the, you can say, the logic part is done in the recursion. After that, you have to only put the things into the different ways. Okay? So basically, knapsack problem you know properly. Now we will come to the certain problems that are based on the knapsack. Shall I need to repeat the knapsack or shall I go ahead? Because in the last class I have completely dedicated the class to the knapsack problem. How to solve a knapsack problem with the help of the recursion. Here we need to write certain logic. Like one is the termination condition when our weight, a item that this array having empty or this weight is empty, then we will return 0. Otherwise we will return the knapsack function. Recursively we will call the knapsack function. Okay. So I suppose you know this problem, and now I'm going ahead and I'll pick the another problem. Let me write one more problem that is the based on this. So if you having little bit confusion over this problem knapsack, then I'll tell you the another problem that will clear your concept. Okay. Subset sum problem. I'm picking a problem that is the variation of this knapsack. We will implement the code that we have written in the knapsack, similar code. Okay, so problem we are taking subset sum problem. Basically in the subset sum problem, what happens? What is this? Here we are having a array. You can say we are having an array. Okay, and inside the array, I'm having certain values. Like what? I'm having certain values 3, 4, 5, and you can say 12, you can say 30. Okay, this is my array, and I'm having a value, a capacity, you can say sum, I'm having 9. My capacity is 9. So what I have to find out? I have to find out a subset from this array that will hold the capacity of 9. If there is any subset is existing that having the sum equals to 9. Like this is array, from this array I can get lots of subset. Like subset is empty subset, subset can be 4, 3, subset can be 3, 4, certain combinations. Okay, these are the subsets. Subset is 4, 5, something like this. So I just want to find out either there is a subset existing inside this array or not. So I have to return only yes or no. Either there is any subset existing inside this array that having sum equals to this sum. So here you can say a subset is existing, subset is, you can say, if I'll pick a subset of 4, 5, okay, 4, 5 and sum of 4 plus 5 equals to 9. So this is the subset existing inside this array. So I'll give the result as a true, or you can say yes. Okay, this is the subset problem. Are you getting the what is the problem statement? First we are seeing the what is the actually problem. What is the problem statement, then how we can relate this problem with the knapsack, and then we will solve this problem, how we can solve this problem. Guys, can you please give me a quick confirmation in the chat window? Are you getting the things till now? Or if you have any question, you can ask me. Because now we are having like very less classes remaining, so I just want to clear each and everything. If you have any question, you can ask me, don't worry about it. Okay, like I have covered almost all the topics of the DSA till now, so you should understand the things. Now it's a time to solve certain problems. Like we are solving certain problems that are based on the dynamic programming. And this is very important topic. Many times I have repeated for the dynamic programming, this is very important topic and this is a little bit tricky. If you get this concept once, then you never get confused. And if you don't get the concept, then you cannot solve problem. You can remember 1-2 problem solution, but you cannot solve the problems. If you get a new problem, you cannot relate the problem. First, you should understand the basic concept behind the problem, how we can relate the problem with the base problem, and then we can solve the problem. So this is the subset problem, and in this array we are having an array, and I can say a subset I can pick 4, 5, and that subset is existing inside this array, so I can return either yes or true. Similarly, I can take the another input. In that input, I am not having a subset. Like a array, if I'm having an array, something like this, here I'm having 3, 4, and you can say 12, and you can say something 30. So from this array, sum is 9. I can say there is no subset. No subset. There is no subset that adds up to 9. Means it's a sum. I cannot pick two values which sum is 9. This is basically problem. Now, how can I relate this problem with the knapsack problem? You can see carefully this problem, and in this problem we are having one array. Okay? And in the knapsack problem we are having 2 arrays. 2 arrays. One is the weight and another one is values. So I can avoid these values. I can say I'm having only one array, that is called the weight. Then I can relate this knapsack with this. In the knapsack we are fitting certain values, and we are having some capacity of the bag. Or here in place of capacity we are having sum. Okay? So we need to find out the sum values. We need to find out either this item is we can include this item or not. We can include this item not. We can include this item not. We will check for every item, and here are the certain choices. Like either I can include the item, I cannot include the item. There is the 2 ways. Okay? So I can create a tree, like for the first item, for a particular item. For a particular item, there is a one choice. Either I can include or I cannot include. 2 choices I am having. So like here, I'm having this capacity is 9, and I'm picking the first element. Like initially I'm having how many elements? Total I'm having 5 elements. So I can say 5 elements and my capacity is 9. So if I'll include the first element, then there is a possibility remaining elements are 4, and capacity I can decrease from this. So 9 minus 3, I can say here 6. And if I don't include this, then also my total remaining items are 4 and total capacity would remain 9. Similarly, now I am having 4 elements. Okay, from 4 elements I'll pick the first element, and I'm taking first element I can include and I cannot include. If I'll include this element, the remaining 3 elements, and if I'll include this element, the remaining capacity is 2. And if I don't include this element, then also our remaining elements are 3 and total capacity is 6. Okay, and here also if I'll include this 4, okay, then remaining elements are 3 and capacity remaining is 5. If I don't include 3 and 9, then also again same thing I'll do. After the 3 I'll come to the 5. If I'll include the 5, remaining elements are 2 and capacity is 0. Okay, further if I'll go down somewhere, I'm including this 1 and 0, I'm not including, and then also I'm last element I'm not including, so 0 0. When it becomes 0 0, it means a subset is existing. Yes, and Nilesh is asking a question, ma'am, what if there are many subsets available meeting requirements? Yes, if there are many subsets are available, here we are just picking, we are just giving yes and no. We will create a, here we will create an array, you can say, that would be our capacity of n cross w, and inside this we are store either true or false. So we can count there is the another problem. In that problem we are counting the number of subsets. That is some enhanced version of this problem. Right now if you finding either any of in a single subset, then you can return the true. If there are the more than one subsets, then we can say we can solve that problem also here, where we can count the total number of subsets. That is the another problem. Okay. So basically the way how we are doing, we are having two things. Either we can include an item and we cannot include the item. Again I'll write 3, 4, 5, 12, 30. I'll create the new. I can write 3, 4, 12, 3, 4 and then 5 and 12 and 30. This value I have taken, and the capacity sum I have taken is 9. I'm again drawing the tree. Okay, so initially total number of elements I'm having 5. 5 elements I'm having here. Number of elements, okay, 5. So I can write here 5, 9 initially. Then for the first element, I am scanning for the first element. Either I can include the first element, there is two choices. Either I can include and I cannot include. Okay, whatever I am doing, I'm just scanning this element. So remaining elements are 4, and if I'm not including, then capacity remains 9. If I'm including, then capacity decrease from the 9, that is the 6. Okay, similarly first is not and second is include. Okay, this is convention I am taking. Again for the next element, that is the 4, if I am not including, then I can say here the 3, 9. If I am including, then I can say 3, I am subtracting the 4, that is remaining is 5. Same thing I'll do for every element. Okay. And these are the basically sub-problems. These are the sub-problems. We will create a matrix also. Okay. Again, I'll complete this tree. Okay. 2, I'm not including 2, 9, or if I'm including the 5, then you can say 2, 4. Okay. And I'm not including the 5, then 3, 5, 2, 5. And if I'm including the 5, then you can say 2, 0. And for the 12 also, I'm including the 12. I'm not including the 12, then 1 or 9. And I can include the 12, then it would go in the negative. Okay. So you can say here 1 and minus 3. If I'm not including this 30, then you can say 0, 30. And here, if I'm including the 30, then you can say 0 and then minus 21. Similarly, for this also, this is negative. Okay, so it won't happen. Same thing we will do for this also. Same thing we will do for this also. For this, you can say, if I'll include 5, okay, here I have done, initially I have done for the 3, and then I have done for the 4, and here I'm doing for the 5. If I'm including the 5, first thing is 1, and then here the 5, and I'm including 1 and 0. And for this also, not including 0, 0, and including, then you can say 0 and minus 12. Okay. So basically when it becomes 0, 0, it means I can say my requirement is fulfilled. Basically we don't go in the negative, just I'm telling you how to create a tree. Okay. So this is the way to find out the negative. Now how to solve this thing? We have to create a matrix. Okay. These are the rows. Rows are n, and let me change the color. And then we are having certain columns. Okay, columns is our W. We are taking W plus 1, and this is we are taking n plus 1. N plus 1 means how many items we are having. So here we are having 5. So we will write here 0, 1, 2, 3, 4, 5. And similarly 0, 1, 2 and W till W. We will create a matrix like this. Okay, and W here is 9, so you can say it will go till the 9. Okay, and for every this we are writing here the solution. The solution of subproblem will be written here. Something like this. So first think about the recursive solution. For the recursive solution, how we can write the recursion to solve this question? How we can write the recursion program? First thing is we need to write the base condition. That base condition we have written in the knapsack. Here, a base condition you can say when we will terminate the recursion. So either my sum becomes 0 or my n becomes number of items becomes 0. Either my sum becomes 0, here my sum becomes 0. So I don't go. After this I don't go. Or either my items empty. Any one of them is satisfied. So if sum becomes 0, sum equals to 0, okay, it means I can say I got the subset. I can return true. When my sum becomes 0, means this condition, sum becomes 0, it means here the sum becomes 0, it means I got my subset. When sum becomes 0, when I am finding two items whose sum is equals to sum. So here when I am finding these two items, 4 plus 5, then I can say I am getting the things. So I can say I will return true. This is one base condition. Or either item becomes 0. If n equals to 0, it means I can say I didn't get the item. Okay. I have traversed all the items, but some is not, I'm not getting the subset. Then I'll return false. I'm just giving the idea. You can solve the problems. N becomes to 0, it means I didn't find the element. So this side the n and this side you can say my weight. So if this becomes W becomes 0, then I can write here true, 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 and true. And if N becomes 0, then except this 0, 0, all becomes false. Okay? So I'll fill the values like this. This is the terminating condition. Now what happens, two more condition I have to write. Either item I can include, or like for a item what happens, here is item like suppose 12. Okay, or we are having one item 5, we are having one item 12. So what we can check, either its value is less than sum. Okay, so item value is less than sum, then we can think about either we can include or not. If value is greater than sum, then we cannot include. Two things. If value is less than sum, okay, element is less than sum, then I can say two possibilities, either I can include and I cannot include. And if element is greater than sum, then I cannot include. Like 12, I never include. 30, I never include. Because its value is greater than the sum. So I have to write two more conditions. If the element is greater than the sum, then I'll ignore it. And I'll go ahead, I'll ignore that element. And if value is less than the sum, then I can write the logic. I'll subtract its value and then I'll go ahead. Let me write the logic now. Okay, here I'll write the same problem 3, 4, 5, 12 and 30. Okay, now I'll write the recursion solution. I'll tell you the recursion solution, then the same thing you can apply with the dynamic programming. You know the concept of the dynamic programming. We can write the dynamic programming also for that. Okay, so the thing is here how to write the recursion. Okay, so we will define a recursive function like subset. Okay, inside the subset what we have to pass? We have to pass our array. Okay, we have to pass sum, or we have to pass n, number of items. Here number of items n equals to 5, you know, we are having 5 items. So this is the recursive function, and inside this recursive function we need to write certain logic. Okay, so here two possibilities, element is less than sum, then we can include and we cannot include. Element is greater than sum, we never include the item. Okay, so for the recursion we need to write the base condition. We need to write all the possible condition. So one thing I'll write here, if, okay, if sum equals to 0, okay, then I can return true. I'm not executing, you guys can execute. I have executed so many programs in the class. So just I'm telling you the logic. And if n equals to 0 means I have to reverse all the elements, and sum doesn't becomes the 0, it means I never find the subset. False. Getting? Now I'll write one more condition. If this array element, okay, this n I'm taking, so n minus 1, okay, is greater than sum. Okay, if this is greater than sum, then I'll go ahead, I'll skip this. Okay, so I'll return here recursive function subset, and inside the subset what I have to return? I have to return array, then I have to return sum as it is, and element is here n, inside the n we have to pass n minus 1, we have to skip this element. Okay, and one more condition, like if my item sum is less than this, then I can write two conditions, either I can include or I can exclude. If sum is less than the item. Okay, so else part, in the else part I need to write here, I have to return in the else. Okay, what I'll return? I'll return subset. Okay, and inside the subset I can return two things. One thing is I can return as it is array. Okay, and then n sum n minus 1. This is I'm not including if. Okay, or second condition is subset. If I'm including, then what I have to write? Array and sum minus, I need to subtract the capacity, means array n minus 1. Okay, and total number of elements 1 decreasing. Two possible conditions. Okay, so this will give you either including, not including, or this is including. Okay, and if this, when I call this, if it is providing you true, it means element is found. Otherwise you can say element is not found. Okay, and same for this is the recursive way. For the same thing we can write the dynamic program top down approach as well as memorization. Okay guys, this is the recursive logic. Same thing, if I just want to write the same program with the help of top down. In the top down, what we will do? We will use this recursion logic. I'll open the another pen. I'm keeping this logic return. Okay, and then I can show you how we can write the another logic that is for the top down. Both are the same way. In the recursion we can use the memorization. In the memorization we can simply store the result. Okay, and in the top down way we are convert recursion logic in iterative way. How to convert the recursion logic in the iterative way? Actually, we will keep a matrix. Okay, we will keep a matrix of n cross w or n cross sum. Okay, we will keep a matrix of n cross sum, and inside this matrix we are going to store the result. Okay, how we can do this part? How we can convert this program into this the another way? Okay, so initially this subset, we will initialize a matrix of subset. Okay, subset matrix, and that will have size of, you can say, n plus 1 and sum plus 1. This size we will keep for the matrix. Okay, and initially in this matrix we can store any value like -1, something like this. Okay, or initially I'm keeping this matrix empty. Then here the terminating condition, I have written this terminating condition. Okay, you can see this condition corresponding to these two conditions, sum equals to 0, I'll fill my table. I'll fill my matrix like this. For this, I can create this, and here you can say if this is the sum and this is n, okay, 0, 1, 2, 3, 4, 5, and total elements I'll keep the n plus 1 and here the 10. So if the sum is 0, it means I'll fill all the true. And if n is 0, I'll fill all the false. So corresponding to this, these two lines, if sum equals to 0, n equals to 0, I'll write the equivalent loop. So here I'll write the two loops for I, okay, for I in range n, okay, and for j in range sum, I'll run two loops, I for the n and sum for the w. Okay, and here I'll put the 0. I'll put false if I equals to 0, means I'll put inside the matrix, this is, you can say, my array, so you can say a of I of j equals to 0, and if j equals to 0, false. If j equals to 0, then I'll put here the true. Are you getting? I'm converting these lines into the iterative way, in the loop way. So I have to run two loops. I for the rows, number of rows is number of items, and number of column is sum, you can say the capacity. So if I equals to 0, okay, if I equals to 0, I'll put the value false, and if j equals to 0, I'll put the value true. So I'll fill these two rows, first column and first row. I'll fill first row and first column with the help of this, and then I have to fill the remaining rows and columns. So for these two conditions, this if condition and this else condition, I have to write the loop again, iterative way. Okay, I have to write the iterative way, so I'm writing the logic here. Are you getting the things? So here I'm writing two loops. One is for the false and one for the true, that you can write. Okay. Second thing is, I need to write the more conditions for the if element value is greater than 0 and greater than sum, and element value is less than sum. So here complete program I'll write. Okay, don't worry. Subset. Okay, subset. Inside the subset, what I'm passing the array, I'm passing number of elements, I'm passing sum. Okay, inside this, I have to write certain conditions. Okay, so one loop for I in n. Okay, and for j in sum. Okay, and here I need to write if I equals to 0, means array of I of j is false, and if j equals to 0, then you can say write a of I, in place of array I'm putting here a of j equals to true. This is for the first condition. Now I'll write for the second condition. Inside this function, I'm writing everything inside the subset function. Okay, then I'll write one more loop. Okay, for I in, this is n plus 1 and this is sum plus 1. I in n plus 1, okay, and for j in sum plus 1, okay. Inside this I have to write the condition if, okay, if j is less than, okay, item is less than, means this j, okay, sum is actually greater than, this j is sum. So there is two possibilities, either sum is greater than or sum is less than. This j represents sum. So if sum is less than the item, item means array of I minus 1, then I can say I never include this item. So I can recall here, I can write here A of I of j equals to subset, okay, I minus 1 of j. This is the condition if my item is greater than, okay, item is greater than sum. One way. Second way is if item is less than sum. Okay. Next condition is if j is greater than A of I minus 1. Okay. For this, what we can do? We can write here two possible conditions. Either we can include the item or either we cannot include the item. Two possible conditions. So here I can write the condition like this. I just want to write in the continuation, okay. Here I can write, okay, subset, okay, my subset, this is not subset, this is actually my array A, okay, that I have defined initially. Array, or you can say subset, that having the size, this array, this I have included the array. You can call it either the subset or you can call it the array, both the same way. This I have defined this grid. Okay. So if I'm writing the function name is subset, then I have to put everywhere the subset. This my function name is subset actually, okay. This function name is subset and here I'm putting the values. This is my array, okay. This is not the subset, I'm just putting the values inside the array. So I can put it, this is function and this is A, okay. This is A having size n cross w. Okay, and the function inside which I'm writing the code, that is the subset. Here I don't call the recursion, okay. I don't call the recursion. So if item is less than the total sum, then I can write here the condition, okay. So A of I of j, okay. A of I of j equals to, you can write A of, either I can include and I cannot include. So first thing is I'm not including, okay. And second condition is I'm including. If I'm including, then I have to add its value, okay. I have to subtract its value from the sum. So A of I minus 1 and from the j minus, you can say you can subtract that value. So here I can write array. Okay, and from the array I need to subtract I minus 1. Okay, this is my array. This is my array. Array I am passing that having total elements. A is my grid, okay, and subset is my function. So if I'm putting the values, here you should put the A. Some conventions I have written wrongly. So just try to understand what I am having. This is A, this is array, and this is basically matrix which I am going to in which I am going to put certain values that having the size n plus 1 plus n plus 1 plus w plus 1. Okay, and this array having total items, array of items, n is total number of items, and sum is the capacity. Okay, so I'm comparing the elements of this array. So when I'm comparing, j is less than element of this array. Okay, and I'm putting the value inside this A. So here I can put the value like this. You can see this carefully. This is very important thing. Here, if I'll include, then what happens? If I'll include, then that capacity, J is represent the sum or capacity. So I'll subtract the capacity. So J minus array of I minus 1. Okay? That's the thing how to solve this question using the dynamic programming. Okay? So this is basically logic, and this is the same logic that we have used in the knapsack. In the knapsack also we have written the recursion. The recursion is the same way. You can see in the knapsack also we are returning the values in the same way. Okay, so this problem is similar to recursion problem. Now I'll tell you some more problems that are also similar to knapsack problem. Okay. One is the equal sum partition. Let me write another problem. Okay, you got it? Now I'll write one more problem. I'll write 3-4 problems, I'll tell you, and you can relate those problems. Okay? So equal sum partition. In the equal sum partition, what happens? I'm having an array. Okay? I can say I'm having an array, and that array having certain values like 1, 5, 11 or 5. Okay, so problem is to determine whether a given set can be partitioned into two subsets such that the sum of elements in the both subset is same. I can create two subset of this subset, and sum of those two subset is equals to the both subset sum is equal. Equal sum partition. Whether we can partition, we can create two subset whose sum is equals to equal. Like here I can say I can create two subset of this array. One is the 1, 5, 5, okay, and another one is the 11. And sum of both is 1 plus 5 plus 5 is 11 equals to this. So I can say yes, true. Second array, if I'll take another array that I can have 1, 5, 3. I cannot create two partitions, two equal partition. You can try all the combinations, but you cannot create. Now, how this problem is related to knapsack? This is the same thing. Here also we need to, either we can include the item or we cannot include the item. There is the choices. And we are having one array, we are having one capacity. Capacity is their sum. Okay? So this problem is also similar problem to the knapsack. Either we can include like a item we can include or we cannot include. Two possible combinations. We need to find out the subset. We need to create certain partitions and then we sum. We create partition 1, we create partition 2 and then we will sum this and we will sum this and then we compare its sum is equal or not. So we need to give the output as a true or false, or you can say yes or no. You can solve this question similar to knapsack problem. Okay? Like what we can see, total sum of these items is 22. And this 22, out of this 22 sum, I can sum. Okay? And I can divide the sum into two parts. Subset 1 and subset 2. Subset 1 and subset 2, 11 and 11. Or this is the even sum, like this having some even sum. Sometimes what happen, it is having some like 21. So for that we can do 10 or 11. Further we can check out. Okay, so these are the things you can compare, you can check out either this problem is similar to the knapsack or not. Similarly, I can tell you the another problem that we already somebody have suggested, count the number of subsets of a given sum. Like a problem you can solve, you can write the problem like this. I'm just giving you the idea that are similar problems. You can solve those problems. Count of subsets of a given sum. Okay? So here what we will do? We will create a subset. Like we are having an array and we are having some sum like sum equals to 9, and in the previous array like you are having certain values 2, 3, 5, 10, 4. And one more item is 6. So here you need to find out how many subsets are available of given sum, that is the 9. Okay? And there are some other problems also like minimum subset sum difference. Next problem I can say minimum subset sum difference. This is also another problem. In this problem, what we have to write? I'm just telling you the problems only. You are having a list of integers and your task is to divide it into two sets, S1 and S2, two sets. Okay? Such that the absolute difference between their sum is minimum. Like I'll take an array A equals to something values 1, 6, 11 or 5. Okay. Now I'll create two subset. One subset you can say 1, 5, 6. Okay. And another subset you can say sum of this subset is 11. And another subset I can pick it 11. Okay. And sum of both subset. Sum of first subset is 12 or sum of second subset is 11. And the difference is 12 minus 11 is 1. So here you can put the minimum subset sum difference. Okay. This is basically extension of partition problem. In that we have divided a problem into two subsets. So basically we have to divide the elements into two subsets. Okay. Similar thing, we need to find out the difference of subsets, all these things. Now one way, another way, there are the different ways of the knapsack. I'll tell you the different types of knapsack. Okay. One thing, certain problems are based on the knapsack. We have seen 4-5 problems. Okay. Now I'll tell you the type of knapsack. Okay. One knapsack is 0-1 knapsack. Okay. Another knapsack is, you can say, in the 0-1 knapsack, what happens? In the 0-1 knapsack, basically we are having a choice, either we include the item or we cannot include. But here we have to include complete item. We cannot break the item. Complete item or only one item once. Once and complete. Another thing is fraction knapsack. In the fraction knapsack, what happens? In the fraction knapsack, like if your bag capacity is 10, okay, and you have full till the 9, you remaining only 1, and you are having element, minimum weight element is 2, so you can fit half of this element. And you will add its half weightage. Okay, that is the fraction. Fraction is giving you opportunity. You can divide a particular item, you can include its fraction. If you are having certain capacity, that is, you cannot accommodate the complete item, then you can divide the item into the parts. Okay, and next is unbounded. Unbounded knapsack. In the unbounded knapsack, what happens? We can include one item multiple times to get the maximum benefit, maximum profit. So these are the variation of knapsack. Okay. Basically, you just solve one problem, that is the knapsack problem, with the in the 3 ways that I told you. One is the recursion, one is the memoization, and another one is the top-down approach. So using 3 approaches, you can solve a problem. Okay, and then you can try all the variations of the knapsack. I can give you the list of variations. Okay, like we have seen certain problems. We can write here a list. Okay, first thing is subset problem, we have seen subset sum. Okay. Second problem, you can say count of subset. Okay. Subset sum. Okay. Third problem, you can say equal sum partition. Okay. And then you can try the minimum difference, minimum subset difference. Sum difference. Okay. And there is one problem called target sum. You can try that also. These are the problems basically based on Knapsack. So if you have clear concept of Knapsack, then you can solve all these problems that are related to Knapsack. And first read the problem, whatever you are getting the problem, read the problem, relate the problem with the base problem, and then try to solve the problem. Then you will solve the problem easily. And solve with all the approaches, all three approaches. Recursive, if you write the recursion, then it's easy to convert that recursion into the memoization and into the top-down approach. Okay guys, so I think this is enough for today. Just try these problems, solve these problems with writing the code in the Python, and then you can solve, you can see, you can easily solve the dynamic programming questions very easily. Okay. So thank you so much. I think this is enough for today. Just try and practice each and everything. Just revise the things. And if you have any question, you can ask me. Okay? So hopefully you are getting everything and you can relate the things. Okay guys, thank you so much. We'll see you tomorrow.